Alright, let's see if we can make it work. Starting stream health, receiving your content. You are live. Yay! Let's see that happen. What happens? Does it like already know that? Okay, I am gonna do a video kind of live streamy that I've been meaning to do for a while, which is to talk about chargers, lightning cables. So are they all one and the same? And the answer is no, and we're going to look at exactly what's the difference between lightning chargers that are cheap, expensive, and what do they look like kind of under the hood, and especially why that's important. So let's start. Here's two different cables that I got on Amazon. Just kind of randomly, I saw some lightning deals for lightning cables on Black Friday, so I bought some. And I noticed, especially with this one's from the Onyx Volt company. This was all over Amazon, sponsored ad, always at the top if you're searching for lightning cables. And I was struck by the price of these things. This was super cheap. These were like 4 for $10. Now I know that it's important, of course, to have the made for iPhone, iPad, iPod cables, the MFI, MiFi cables. I know that's important because those have a chip inside the cable that will protect your device from voltage fluctuations that can kill the device. So I was only going to buy ones that said that they were made for iPhone. So this one, it says right here, MFI certified cable with a big word guarantee. And if you look at the listing for this, so let's go ahead and see if we can flip over to screen. Sometimes screen flipping over gives me a hard time. Okay, live dashboard. Let's see. Here we go. Let's see if we can make that work. I don't know if you guys can see that. Probably not. Let me know. This is what we're talking about, the 4-pack Apple MiFi certified. And it has the logo there, the made for iPod stuff. And you can get 4 of these for only $12. So that makes them $3 each. So that is a price that is like too cheap to be possible. So that's why I bought those. And then I bought another one that I also thought, might be sketchy. I don't know. This is from RAVPower, and the RAVPower listing is, I think I have to click to make the screen active first. RAVPower. Let's go over here. Screen. Maybe you guys can see that. So these are 2-pack, 2 of them for was $25.99 for $14. So that's $7 a cable. That's a lot more reasonable. So let's take a look under the hood on these, and I will show you what to look for. All right, so let's take them apart. So we're going to start with the RAVPower ones. So let's see what these look like. Thank you for your purchase. You are welcome. Thank you for not lying about your product. All right, so this is a short cable. Let's open her up. And feels kind of cheap and plasticky on the ends, but the cable itself feels pretty pliable, and it seems pretty high quality. It's not the total bright white ones that just look like they're going to fall apart. So now what's important is the lightning end. So let's cut this sucker open and see what's inside. And that's the important part here. So we're gonna do that. Let's go under the microscope. All right, so here's what this looks like. And some of you guys are cable gurus and can sort of tell whether or not something is like original based on this sort of external appearance. So it looks like that. All right, let's cut it open. We're going to sacrifice this one. And this is what you have to do. I mean, you have to be willing to sacrifice your cables every now and then, just so that this is the only way to truly know what you're getting here. Let's just go ahead and put this back on camera. So I'm just going to take some cutters and I'm going to try to get eyeballs on the underlying chips, the little board here that actually makes up the connector. So we're going to kind of just dig into this any old way. So layer one is a just plastic surround, and then you get to the nuts and bolts of the cable and it's metal. So let's look at that. So I took off the sort of outer surround, and you can see this is sort of a fully encased heavy duty metal. So that is reminiscent of a bona fide, certified, made by Apple, the connector. This little tiny board here, the connector, and that's the piece that the accessory makers will buy from Apple in order to be able to make whatever the heck kind of interesting or weird cable they want to make. But it'll be certified as long as they are sourcing this piece from Apple. Now that's not cheap. This piece, this little tiny connector, costs something like $4. That means you have to sign up with Apple and be a bona fide, legit, let's try to dig this up over here. A legit person who is willing to pay $4 for this tiny thing and make a certified accessory. That is what gives you the right to say, hey, this is made for iPhone and it's certified. So let's try to drill down into this so you can see it. I might give up and just kind of, these things are tough. I'm trying to cut it in a way that you'll be able to see it without really destroying it. The last one I pretty much destroyed. This is hard to get into. This metal stuff. And this is probably not the best tool for the job, but what the heck? Sharon?
Yes?
Can you get this, open for me? How am I supposed to get into this?
What do you have?
I have a piece of metal. And I need cut. Do you have a better tool for this? See how that I need to unmetal it.
Yeah, hang on. Let me see what we have over here.
Oh, all right. Oh wait, I've got some progress going on.
Here's some needles.
Wait a minute. I got progress. All right. Alright, we are, oh that's nice. Look at that. Oh yeah, that's the right tool. Thank you.
Gee.
Now I'll steal these.
Oh, you want them?
Okay, so where are we now? Alright, let's see. I got the metal thing off, and now it's time to kind of dig down to the final layer here. So we'll slice into this. And I see chips, and that's a good sign. All right, here we go.
Where'd you buy those?
I bought these on Amazon, and Sharon, I will provide you with my Amazon affiliate link if you please stand by. Actually, I have to make that. I'm gonna take one. I did a lot of research on this, so this time I'm gonna actually make my Amazon links and not let Lewis come by and put his Amazon links for the chargers. He can do everything else, but this one I'm gonna do. All right, so here's the deal. One side we have chips, and the other side, let's look at the soldering here. And the other side we have just cables connected to pads. So This piece here is the Apple produced, this is my understanding, and maybe I'm wrong, but my understanding is that this cable, this whole piece, this connector, is one of a few different flavors that are actually produced by Apple and sold to people that sign up and pay for the certified, MFI certified program. So if you want to make a karaoke machine that's powered by an iPhone, you can, and you'll get this guy to do the job. Now here's what's important about the chips. There's a bunch of chips on here, but two of them I want to call your attention to. So the first chip is this one here. It's sort of rectangular, and this is the one that sort of gets all the press. This is the E75 chip. Now the E75 chip's job is kind of a negotiator chip. So if you remember the old 30-pin port, that's a lot of pins, that's a lot of information, that's a lot of data. And now that's condensed into whatever 8 or 9 pins of the lightning port. And so this chip is sort of able to negotiate, what's going to happen on these lines depending on what you plug in. So this chip has the ability to tell the listening chip, the TriStar chip, on the phone, hey, I'm a bona fide Apple certified charger, and I'd like to provide 5 volts of charging current so that you can charge your battery. And TriStar will say, okay, what's the secret password? And the thing says Steve, and it says, okay, you're legit, and then it's going to let that happen. So E75 also, in theory then, could have the logic to send lots of other different messages that could basically negotiate a lightning connection with TriStar so that either the device could receive accessory power from the phone, like, hey, I'm a fan, turn me on, I need 3 volts, or be some sort of a charger, or be some sort of a speaker dock, or whatever. So that's what E75 does. It's negotiating that lightning interface. And that's the chip, this E75, that's sort of super popular, because if you're in the business of saying, hey, nobody wants to pay $4 for this board, if I could make that board for like 25 cents, I could make cables for $1 or $2 and make a profit. And everybody in the world would rather buy my cheap cables. All I have to do is come up with a chip that can fake that message. So I need to come up with a fake E75 that can say, hey, I'm a charger and I'm totally legit, bro. Let me in. And so the entire business of these copy chargers are all really centered around how do we fake that E75 message. And if you go look for this stuff, if you even start just looking for the word E75 and charger in China, it's crazy. I mean, keep in mind the reality. In order to get a bona fide board with E75 on it, costs you $4, plus whatever it costs you to make your cable, plus profit. So the cheapest that anyone would legitimately sell this certified board would be maybe $5. That would be maybe $4.75. That would be the cheapest way you could ever get a bona fide MFI certified board. So anybody that's selling a cable for $1 or $2 or $3, it's not gonna be a actual certified board. So those guys are all selling some variant that's gonna have some kind of a fake E75 chip. And then they have all of these readers that are also fake that you can buy the reader, the head reader, so you can plug in the cable. It'll be like, oh yeah, that's a bona fide E75. Oh, that one's copy. Oh, this one's bona fide. And so that you don't have to do this and cut up cables in order to know what's going on. But the problem is that a lot of those readers are also fake. Anything that says original from Foxconn, always fake. Anything that says 1000% OEM original, definitely fake. So that's the deal. But none of that is really important. Who cares if it was just as easy as that, fake E75, who cares? Real one, who cares? The thing that's important is the thing that nobody talks about. The thing that's important, this is why I'm doing this video, is the other chip this big square dog. So this guy is a really sophisticated chip. It's by NXP, who's been around for a long time making chips. And this thing is a load switch, and it has built in, if you go and look up the data sheets, this thing is called the NXP, I think it's the NX30P or NXP30, no, NX30P3, that's what it is, or NX20P3, I don't remember. Look that up, and you'll get to a family of these NXP charging chips. And you can find out these names and all by looking at who the first guys to do a really great dissection, which was ChipWorks. And they have their dissection of the lightning cable and kind of their X-ray analysis of these chips and kind of pointing you in directions of their guesses as to what they do. But so they can point you in the direction of looking up the NXP chip here. And it is in a family where if you read all those data sheets, the family, it's pretty clear that these guys are sophisticated with current limiting functions, over voltage protection, reverse polarity protection. They are very quick to shunt the incoming 5 volts from the charger to ground, to turn that off and not let it get into the phone if there's any kind of voltage problem, any dysregulation, really any kind of a surge or ripple voltage on the line. That chip is very sophisticated, and it is not going to allow that to go up the cord and into the lightning port and go into the device. That's really important, because remember, the phone thinks that there's this sort of security with E75. So as long as the phone thinks, if there's an E75 that says, hey bro, I'm a legit cable, you can trust me, then the phone is then going to defer the voltage protection to the chip here that's in the cable. So if you combine a cable that's missing the NXP sophisticated voltage protection chip, if it's missing that, and it just has some kind of E75 that's able to go, yeah bro, I'm legit, then you are in a really bad situation where you are now, the phone is potentially disabling some on-device voltage protection and deferring that out to the charger, and it's not there. So that's how you really get set up for these massive TriStar problems that we see all the time. And that's why these cables are so important. So here's the deal, what's important, this is what I would call a bona fide, made-for-I certified charger with the NXP voltage protection chip and the E75 negotiator chip. So this one came from, let's review, this one came from RAVPower, and it wasn't super expensive. These are $6 or $7, which is what you would expect to pay for a original MiFi cable. Now let's look at category 2, the people from Onyx Volt. Now remember, this listing says guaranteed 100%. It had the logo, made for iPhone, made for iPad, made for iPod. And let's open this one up. All right, let's see if this is even working before I go too too far down the rabbit hole here. Let's see. Are there any comments? Yo, okay. Audio is not in sync. Yeah, something's up with the audio. That's just too bad. Audio out of sync. Audio. I'm not gonna fix the audio. If you don't like the audio, click X, go away. I'm not going to investigate that. Recently got my lazy ass to cut them open to check for the proper ICs. Amazing how many that were advertised as MiFi were not. Audio's out of sync. Got it. It's snowing out here. Insanely hard to get to the ICs, yes. I'm reading the comments. That's $4 you owe Apple. Uh-huh. How did you? I figured it out, man. Read. I don't know. I just Googled a lot. That's right, the internet. One of these kinds of videos on the whole genuine, non-genuine screen. I don't know enough about screens. How good are the Amazon's basics? I don't know. I haven't done that. You check I think you guys check whatever you have. Come back and post. This will end up being a video. So cut open your cable, post back the brand where you got it from, and if it's original or not. All right, let's go on. And if the audio is annoying, then we'll just put this on like Microscope so that you don't have to see lip syncing going on. So this one is the Onyx Volt. So let's check this out. So this claims to be certified, and you know it's a fair. As far as construction, it seems pliable. It seems, you know, pretty much like the other one. And let's go ahead and cut into it. Let's lift this up a little bit and look here at the end to see if we could tell. That looks a little bit shoddier. It looks breakable. You can see the seam all the way around there. Okay. Alrighty. Now this one's going to be easier to cut.
Should be Ivan.
Yeah.
He's been invoiced $55.39.
Yeah.
So he's on set. Let's throw him in there. Does shit work?
It does, except for no backlight, Sharon.
So that you can't see it.
Oh, it's him.
So you can't see it.
Yeah, it's the guy that set the phone up to erase and then sent it to me for data recovery.
Okay.
Yeah, that's out. So that was easy enough to get off, and let's drill down here.
92. 2364. Yeah.
Okay.
I've got a data thing. Phone's- and his phone's-
That one, Sharon, is rush data and should be ready to go. That data is burned, that drive is burned, ready to go.
Okay.
So if he's put together, just invoice and that's it. Alright, so this one does not have the metal surround, surprise, surprise. But surely it will have the same chips since it was a MFI certified cable. The internet told me so. Alright.
Rushing.
One of you guys, can you babysit the data recovery up there? I think I pulled over his pictures. It's also Rush, I think. So you can start a backup. Okay, internet, this is a big fat lie. We have been had. This is not the certified board at all. I mean, that's super obvious. This is what the Chinese fakes all look like. So if you don't know what they look like, this is what they look like. This is important to learn. This is fake. You have one or the other of these dudes is the fake, you know, E75, hey, I'm Steve chip. And the other one is, you know, some 3-cent non-NXP load switch. And together they can kind of charge your phone as long as E75 fake says, hey, you can trust me. And then this guy doesn't happen to catch on fire the time that you're using it. And you're kind of on your own whether or not this thing is going to allow some kind of surge, voltage ripple, over voltage, reverse polarity, whatever, to come crawling up the cable. All right, let's see if we can do our side-by-side comparison. What happened to that cable? Oh, I stuck it back in. All right, let's compare. So this is on the right, copy, and this is bona fide on the left. So you want to see the square NXP chip. That's what you want to see when you dissect these cables, and not that. All right.
Did you have to use again?
Okay, so that's the lesson. Now, the next thing I want to do with you guys is to look at the schematic and see, okay, so what's the big deal? Let's like follow through and see what does the schematic tell us about where these lines actually go, and see if we can kind of predict the consequences. Like, so what's the big deal if you use one of the cheap chargers? Why is that bad? So let's drill down on that a little bit. Let's see. I need you to tell me whether or not you can see these schematics. So I'm going to pick iPad Air, TriStar area. Actually, we should probably start with a dock. Let me switch this over to screen, and hopefully you can see that. Let me check to see if you're able to see that. All right. So it would be bad to use one of these cables and start your car while charging through the circuit. Absolutely, that's the #1 worst thing that you can do. Yeah, we can see it. Fantastic. All right, so hopefully you're looking at the schematic along with me. Otherwise, it's going to be really lame.
Isn't that nice?
Okay, so here is the iPad Air TriStar chip, and the actual this side of the chip is what connects to the Lightning charger. So we could follow out these lines, and ultimately they would get to the dock connector and go through and connect with the Lightning cable. So we're not going to do that. That's gonna take too long. Let's just sort of look and see if we can make anything out about what does this chip do. So let's just try to think about this. So on the left side, I see a lot of words that you can Google and say, when I Google JTAG and UART, blah, 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 when I Google a lot of this stuff, what does it come up with? Things that if you kind of had to just sort of put it in a nutshell, you would say, in a nutshell, these have to do with data. This is all chitter chatter, debugging, talking to the chip, and getting information back out. So let's sort of say all of this may not be important for kind of day-to-day stuff. This sounds all like kind of debuggy stuff that maybe was important in communicating with the phone during development, or who knows what it's doing now. This side over here on the right is the part that is more important for what's going on with the charger. So let's see if we can guess what's going on. Let's guess, what do you think this pin does? E3. Now I don't know. I'm going to share with you my hypothesis when I look at this and tell you what I get from this, but you're free to debate or tell me I'm wrong and to tell me what you think. Here's what I think. I think that when I see a line that says E75, well, I know what E75 is. E75 accessory detect. That's what that sounds like to me. And it says connector detect. I'm going to guess that looking over this whole chip, this pin is probably something that lets the phone know that you plugged something in. So let's see if we can follow it along a little bit. I see, here's some protection. I see a diode. Now, and if you follow this out, E75 ACC detect, and you were to copy that, it would go to the charge port and then onto the actual Lightning connector. So we can see that it looks like, well, that says no stuff, so there's no connection to VCC main there day to day. All right, so this is going to be a signal that tells the chip, TriStar, hey, somebody just got plugged in. Then if we look at these very similar lines, P and N, these are going to be data. These are probably going to be data information that is between the device, this accessory or charger, karaoke machine or whatever, and TriStar. Then this one here, PP out, E75, accessory ID1 and ID2. From looking at, this accessory 1, accessory 2, from looking at the TriStar chip and a whole bunch of different, schematics, iPhone 6, iPhone 6S, iPhone 5, iPad 4, iPad Air, all of these, iPad mini, then they name these a little bit differently. And from what I gather, it sounds like these would be the accessory power out lines. Here's the accessory power from the power management chip that would come through accessory power, and TriStar could choose to send that out to power your karaoke machine. So that leaves us with this one. So this is a big dark line. So this says VBus, probably protection. VBus protection. This is power in. This is the 5-volt line that comes, that's actually the 5 volts from your charger is coming up through this line. So this is what the device is expecting to be kind of filtered clean voltage from the charger, because of the NXP chip should be doing its job out there on the charger. So that comes into TriStar. So TriStar is really kind of a punching bag chip that is sitting there facing the outside. It's facing the charger voltage directly. So anything that's going on here is really going to punch TriStar in the face. And then you could kind of say, well, what would happen with any of these lines if they failed? Then what would be the effect of that? So then, here's the big one down here. These I2C lines are data lines. And if you follow them around and say, who do they talk to? Well, they talk to everybody. This is sort of like a whole house intercom for the device. These guys talk to the CPU, they talk to a bunch of other chips like backlight driver, chestnut. A lot of them are on these I2C data lines. So if those lines were pulled down because of a defect in TriStar, because it got punched in the face with your crappy knockoff charger, maybe your whole phone's not going to boot. And that is one of the symptoms of TriStar failure. The rest would be failure to detect. If this guy gets permanently shorted to ground because TriStar got punched in the face, then you are no longer, no matter what you plug in, it doesn't know what it is. How about this one? PMU, so out to power management chip, USB brick ID. I don't know what brick ID means, but it might mean like an identification of your charger. Like, are you using the iPhone charger versus the iPad charger, something like that, where it could be telling the power management chip what to expect. Like if this is the tiny charger that's rated to go up to 1 amp, then you should allow 1 amp through here. If it's the iPad charger, then you can allow up to 2, something like that. But you can imagine that if this line was damaged because of internal damage to TriStar, that maybe you would get one of those accessory not supported. It's not able to identify what charger it really is, because that line's down. Or maybe the same thing with one of these lines, the ones that we kind of have a lesser understanding of. Who knows? But here's one that I really think is kind of interesting, and I'm not really sure about this. So somebody that's one of the electrical engineers that comes around here will come by and school us, and I think that'll be fantastic. But let's just kind of make some guesses here. So it's kind of fun to think, what if the story goes like this? So here at this D6 pad, power gate enable, and then OVP. Should we guess over voltage protection switch enable? Sounds something like that. So over voltage protection, that's probably what OVP stands for. So let's kind of follow that a little bit. So we're going to go up here and we're going to search and we're going to type that in and hit next and see where it goes. So this over voltage switch enable line is coming from TriStar. So let's say the story goes like this. TriStar talks to E75, fake or real, and it recognizes that something's been plugged in. So it says, aha, I've been plugged into a bona fide charger. So maybe I'm going to activate this over voltage protection switch enable line. And here's what's really interesting. Look at the name of the spot that it plugs into. Now this is on the power management chip. So on the PMIC, it plugs into this thing here. VBus, so the charger line, overvoltage protection off. What? So maybe there's more to this that my pea brain doesn't understand, but you could make an argument, maybe it's wrong, that what if it's that once TriStar says, hey, there's a charger detected, that then the onboard overvoltage protection is turned off because it's now deferred out to the lightning cord. Could be. I don't know if that's true or not. I'd like to hear your thoughts on it. But they all have some sort of various flavors of this same thing. Yeah, this is that same spot. VBus overprotection off, and then it should probably go back to TriStar. Yeah, here we go. Yep. So that's where that comes from. So the bottom line here, and I think I'll go back to camera and you'll just have to deal with the audio being out of sync. So the deal is that from what we know is that no matter how it happens, that when you use the cheap, non-certified, non-original, and the non-MFI cables, when you use the gas station ones, that those can work fine for a long time. But then one day, there's some kind of a surge or a ripple or whatever, a spike, a lot of times associated with car chargers, that comes up your device and with no protection damages the TriStar chip. The symptoms of that damage can be pretty broad because TriStar does so many weird things. So it could be doesn't recognize that you plugged in anything, just doesn't detect it at all. It could be that it registers that you plugged it in, but it says accessory not supported, even when you've gone back to the original Apple cable. It could be that it will recognize the cable and accept the cable, and it will tell you that it's charging, but it doesn't actually pass through that voltage to initiate charging. Or it could be that it, I guess, just doesn't turn on at all. And that's a big one. If you get one of those data lines that is sort of the PA system of the phone that's routed through TriStar, and that's pulled down because of damage to TriStar, you've got sudden death on a phone because you cheaped out by a difference of like $5 on your $700 handheld computer. So you have to know what you're getting, and you have to buy either original $19 Apple cords or buy one of the ones from one of the actual people that are certified, that are paying the $4 to Apple, and then expect that you need to pay the $4 that they paid plus their profit and their materials in order to get a bona fide cable. All right, so that's what I wanted to say about charging disease and the importance of cables. I've got one here that's a potential TriStar job that I was going to fix. I might cut that into a different stream. I'm not sure if I can. I doubt I'll be able to heal any of this audio stuff. I need to get a different microphone anyway. So let's check on the stream comments, and then I think I'll be done. Yeah, Jessa wrote, oh, by the way, Jessa absolutely pre-searched all this, and Jessa wrote a blog that I think is really, really important, and I'm going to post that a little bit later. Let's see. Yeah, we can see it. I'm adding NXPs to all my dollar chargers. Well, I guess you could do that. All right. Vast majority of dead U2s car chargers. Yes, car chargers are phone killers. Did you check ULab wiring are the certified? I don't understand that. Basics are good. All right. Wait, basics are good is from the same guy that says I'm adding NXPs to all my $1 chargers? The fake sellers are getting roasted. Yeah. Anyone heard of C40? Yes, C48 is the name. I didn't know this for a while. This is my impression. I could be wrong. My understanding is that C48 is the name of the little board. So there's a couple different flavors of this, but the common one that's used to make chargers is the C48 board. So when I'm talking about, original, I think this whole piece is called C48. I thought originally that this chip here was not E75, it was C48, and maybe that's true. I couldn't differentiate that when I was researching this. I researched all this for my talk at ERC, and that was unclear because it seems like this whole connector is called C48, and then they have some alternate versions depending on, if you wanted to do a different accessory with more accessory functions. They have a couple of versions of this board. So whether or not that is E75 or another Apple sanctioned version of E75, that I don't know. But what I kind of came up with is that whole piece is called C48. All right, let's see if there's anything else in these comments before I cut this off. Detects when the cable's plugged in. Sounds right. Follow it. E75, start from E. Okay, jeez. Yeah. Ha! The quick 861 DW on the bench. This dog, how is this performing for me? Well, let's find out. This just drives me crazy. So I ordered this a few weeks ago because I was like, just like everybody else, looking for, what are some affordable alternatives? We do the course in here, there's 8 stations set up all the time, and I want to always be able to make the best recommendations because students come through here and they're always wanting to go home and buy equipment. So I thought, hey, this it seems to be what China likes, and a lot of other folks. So I was making an order from Union Repair. I should do another video that kind of reviews some of the cool stuff that that I got from them. Like, I do really love these board holders from Union Repair, fantastic. I don't like this. Finally got one of these things. Boo. Maybe I just need to put batteries in it, but I thought I was so thrilled. An electric driver, who doesn't want to zip these screws in and out? But it's kind of like, grandma motored, so that's not working. So boo on that, unless it's just, it came with bad batteries. But this thing, got it all set up, and I was excited to test it out. Then yesterday, I'm watching one of Lewis's videos, who I'm already he's on my shit list anyway, because I just took my kids to a day in the big city for my 10-year-old's birthday, and I was gonna meet up at the ice skating place with Lewis, and we were gonna just watch the kids skate. So I dragged this giant bag of 4 MacBooks to Brooklyn, which is hard, and the Uber driver jumped a curb and went up some walkway, so we had to walk really far. I'm carrying bottles of wine and all of these MacBooks, and then he's like, oh, I don't feel good from working out with an injury, blah blah. So he's already on my shit list. Then I see that I'm watching this video that he did, and he's like, I'm gonna review the quick 861 DW. Motherfucker! I'm gonna review that. I already have it. Here's the thing. If you're in the US, it's gonna suck because they're all 220 volt devices. So tomorrow I have a step up converter that I had to buy. So then it's not that cost effective anymore if you have to buy the power inverter in order to be able to run that thing. But I do kind of like it in theory, if it actually turned on. I mean, it senses when you pull it off. I like the nozzles. What I really like is that you, in theory, have the ability to change these channels to presets. The JVC may do that as well. I've never bothered to figure it out. But I like to be able to have shield removal setting and, general desoldering, and then a, lower temperature thing for clearing underfill. That sounds fantastic. So I like that idea. But when you turn it on right now, you can set the temperature. and it'll start. But I'm like, maximum air. This thing's supposed to pump out like 12 liters per minute or something. The JVC only does 7. And I'm like, that is not any kind of 12 liters. Something's up with that. And then I realized that it needs 220. Fuck. Thank you for letting me know that the video is out of sync. Let's see. Alright, let's see if there's anything else. A general idea of what failed TriStar readings. There is no quicker diagnosis than like a 5-minute chip replacement. That's the thing. People are always wanting to diagnose TriStar stuff, where it's like, here's what diagnosis looks like. Desolder TriStar, solder on some leads, solder that TriStar back, get out your oscilloscope, start reading data off of those lines, compare it to known good, and look for missing data or highs or lows or whatever from these internal, spots under TriStar. Or once you desolder the chip, you just put another one on there and see if it works. That is the diagnosis. Replacing TriStar is a maybe 5-minute job, and it itself is a diagnosis. In fact, maybe I should just do this one just to kind of make that point. Oh yeah, it could be. Our cable really did kind of get fucked up. Alright, I think I'm going to cut this off and make a video on this 6S TriStar job so that I can address this audio issue, because I know that it's annoying. It was annoying when I was editing the other one. Alrighty, we're done.